is, and how you can play around with hooks and their technology. But thank you again, and I'll let Hardik give a more proper intro.
Absolutely perfect. Cool guys. I won't take up too much of the time from these guys today, but we have Ishan and Nader with us today from EigenLayer. And it's kind of like workshop's kind of split in two parts. There's going to be going over sort of what EigenLayer is, how it works, some ideas, the request for hooks challenge, participation in the hackathon, and then also going over getting started building your first AVS, so like a Hello World AVS example. And as usual, the workshop is recorded, will be posted shortly after this is over, as soon as Zoom finishes processing the video. So yeah, it's been a long time coming. We've been waiting for this. There have been a lot of people asking questions already before the workshop. So I hope all of your questions get answered today. And yeah, I'll hand it over to you, Ishan.
Thanks, Bhomik. Thanks, Hardik. Really excited to talk with all of you guys today. Uniswap is actually the first dApp I used on chain back in 2020, and also the first like Uniswap V2 was the first smart contract that I forked just to learn from. So really excited about this. I'll share my screen. Let me know if you guys can see. One sec. I've not done this since my university days when I was a TA.
We did see.
I see your screen.
Okay, perfect. Yeah, so just some quick notes is that like Bhomik and Hardik said, this presentation is split into two parts. Mine is more theoretical, talking about what is EigenLayer, what is Uniswap v4 hooks, or not what is Uniswap, like how can Uniswap v4 hooks and EigenLayer work together. And then from there, I'll pass it off to Nader, who is much smarter than I am to dive into some of the actual code. Feel free to just reach out when or like raise your hand or type in comments whenever you have questions. I have two screens open, so I want this to be as interactive as possible. Yeah, okay, sounds good. So first things first, I think that Uniswap v4 is the end game in terms of AMM like AMM mech design. Uniswap v1 was revolutionary for allowing anyone to exchange on token swaps on chain. Uniswap v2 made it more efficient with ERC to ERC20 swaps, flash loans, and oracles. V3 was so good, so underrated. It enabled concentrated liquidity and it effectively brought the real world of trading to life, which I thought was awesome because V2 was still like quite capital inefficient. But I think V4 is different. It's not an AMM, it's a platform to build any on-chain exchange. And I think that's so powerful because it really what you have if you want to change if you want to build a new innovative AMM, you kind of have to separate this innovation from the existing liquidity and where the users already are. Look at Osmosis. They do some incredible stuff like with threshold encryption. And it's kind of sad that like they've done well as a team, but if it was part of Uniswap, it would be 10, 100 times bigger. And Uniswap v4 enables that. So we at EigenLayer are just super excited about Uniswap v4 as a whole. Now I want to talk about like put this idea of you can reinvent any AMM on chain into practice. And we're gonna talk about CowSwap, which stands for Coincidence of Wants Swap. I'll explain their mechanism design, and then let's see if we can try to recreate this with Uniswap v4 hooks. Again, feel free to jump in at any time. So what is CowSwap? What it does, oh, I did not realize Okay, perfect. Yeah, there's a cow tomorrow. Yeah, what CowSwap does is that it effectively matches these buy and sell orders. Now I'm gonna see if my thing actually works. Perfect. Yeah, so let's say you have the ETUSDC pool, right? And I'm just going to uh use this pool for the rest of the presentation. And let's say you have like, oh, I want to buy 5 ETH, someone wants to sell 5 ETH, someone wants to buy another 2 ETH. And what effectively CowSwap will do is that it'll aggregate all of these transactions and say, hey, normally what you would do is you're going to have 5 ETH go against the pool, they're going to pay fees. Another like negative 5 ETH go to the pool and they're going to pay more fees. And then 2 ETH is going to go to the pool and they're going to pay more fees. So how can you make this more efficient, more gas efficient, and have fewer interactions with the pools, and have traders pay fewer pay fewer fees to LPs? And the way to do that is use this positive 5 ETH and negative 5 ETH. And now we like match these to each other, so they're not paying any LP fees, and it's only this 2 ETH that goes to the that's going to the settled on the on-chain pool. And they do some complicated stuff with, rather than having the 2 ETH go to an on-chain pool, it's to a solver auction. They do some like MEV stuff and allow you to sign a transaction without paying for gas. We're not going to talk about that now. It's pretty easy to include that after. And effectively what you're doing is you're reducing the fees that they're paying by like 6x. So this is 1/6 the amount of fees. And the question is, can we recreate this awesome mech design with Uniswap v4 hooks? Any questions so far? Okay. Again, feel free to just blurt out or go in comments. So how do we actually go about the mechanics of matching orders? Because usually when you have an order, like if I want to buy 5 ETH, then I'm going to send that transaction into the mempool, and it's going like there is no logic for me to let this transaction sit and then later get matched with others, and then only later get matched with others, and then a portion of it can get settled on chain. That notion doesn't really exist. So one thing we can do is say, let's add in a middleman. Yeah. Let's add in a middleman, and this could be like a single node operator, and they're going to aggregate all of the transactions here that we talked about. They're going to just split the difference between swap the 5 ETH and 5 ETH amongst each other, and then they're going to put the 2 ETH order onto the pool itself. Settle it with the pool itself. And that's really cool, but what it leads to centralization, and that's a big no-no. Why? It's because we have potential censorship and liveness issues, and we really want to make sure that anyone can transact on chain. I think that is super important for us. If anyone can transact on chains, if you take that away, then you're kind of recreating this old financial system. And what you can do instead is send it to a network of node operators. So now, sending it to a network of node operators kind of like solves all of our problems because it's decentralized, but it also enables all of this. It also enables us to like match the orders together and send it. Let's walk through the mechanics of how that goes. So let's say we have 3 operators for now. Let's just call them A, B, and C. We have our 5 ETH plus 5 ETH minus 5 ETH and plus 2 ETH again, right? And again, this is on the ETH USDC pool. And so we're going to randomly choose, we're going to randomly choose one of these pools, or like one of these operators, and give them all of these orders and say, okay, why don't you match these orders so they're going to do the same thing, and then place the rest of the 2 ETH. You're going to put it on chain and place it with the rest of the pool. And you can effectively do this in a way that's permissionless by just having them sign, like having these traders, by having them just sign transaction signatures and giving that to randomly giving it to A, B, or C. Now, there's a lot of optimizations that you can make to this. I'll just walk through them really quickly. So you could settle the remaining orders. Like I said, you could do that via just putting it to your LP pool, or you could do an auction amongst A, B, and C. You could protect users from MEV just by having the operator go through like flashbots rather than the public mempool. You could enable users to just sign a transaction and not pay gas. That's fairly straightforward. You have these traders actually sign transactions, and then the gas fees, or what would come from gas fees, is actually paid by the operator themselves, and then they take a small cut of fees from like the sell side order. So if you're buying ETH and selling USDC, then they get some of the USDC, and vice versa. So those are just like UX optimizations. But effectively what I want to show is that you can have this decentralized network of like operators, and you can also have these traders, and effectively with the power of Uniswap v4 hooks and this decentralized network of operators, you've effectively recreated CowSwap. So I saw a few questions in the chat, so I'm going to just answer those first. First one was, I think, Robert Leifke. Good to see you, Robert. So fees earned by the LPR 1/6 or the swap fee for the trader is 1/6, both, right? Because the fees earned by the LP are the same as the swap fees for the trader. And so you might be asking, isn't one thing good for if it's good for the traders, that's bad for the LPs? Isn't that overall like neutral? And the answer is no. It comes down to market dynamics. I actually built a DEX beforehand, but effectively you want to, when you're building a DEX, you want to optimize for the taker experience, and then makers will come as long as the yield makes sense. But that's more of a philosophical design decision, so I don't want to talk too much about that. Long story short, it's more capital efficient. Other question by Hyung Suk. So you want EigenAVS to match orders on Uniswap v4 as in form of limit order. So first off, no AVS exists yet. I'm just talking about this decentralized network of operators. The word AVS has not been brought up yet, but will soon, so you're ahead. And these are going to be market orders, but some of the market orders that can take up to 30 seconds to process or so. And then the rest of the pools will, or rest of the taker market orders will go and be settled on the pool. What are the advantages of achieving this using Eigen's AVS? So the reason is that you can have this you need someone to match these orders together, because it's going to be you need someone to match these orders together. And the reason it's harder to do that on chain is because usually when you send a transaction on chain, it gets executed atomically, but you want to batch many of these transactions together. There are workarounds to do it on chain entirely, but those are more complex and lead to other externalities that just having a network of operators solves. Happy to talk more after. So you guys mentioned in the comments about EigenAVS. Let's dive deeper. So what is EigenLayer? EigenLayer is an infra platform that what it effectively does, it gives you access to this decentralized network of node operators. Let me see if I can change my yeah, this decentralized work of node operators. And what the operators are willing to do is that they're willing to run your arbitrary node software, which is willing to run your arbitrary node software, and then they're economically aligned to act honestly with your protocol. So very excited, very excited for to explain exactly how that works. We call these actively validated services because it's an infra protocol that's like a service, and it's validated on by these node operators. So we have this actively validated service. So how does EigenLayer work as a whole? And usually we go with the restaking paradigm. So if you've seen a lot of marketing material, you've probably seen it from the restaking paradigm. I'm going to go from this decentralized network of operators paradigm because that's at the end of the day what matters. You want to build a decentralized service. In this case, it's a cow swap, right? Like Uniswap v4 cow, right? And that is effectively like this is like your app layer. And in order to build this, you're creating this this like decentralized this decentralized matching engine. And what this decentralized matching engine is doing is it's effectively enabling your application. And this decentralized matching engine is going to be the AVS. So how does a decentralized matching engine work? Well, you have these operators, right? I'm just gonna draw these boxes for operators. And they're all contributing to the decentralized matching engine through some mechanism. Maybe it's proof of stake, maybe it's just like randomly chosen, maybe it's proof of authority, though I don't really recommend that. And so you have these operators who are, again, willing to run your stake. And again, remember the most important part. You want to make sure that these operators are like incentive aligned with your protocol. And so what you do is you'll likely have some fees that go to these operators. We already talked about that. That could just be like they take a small cut of the like fees instead of paying, like they pay for gas and take a small cut of the swap fees. But you also want to make sure that they're not malicious. And in order to do that, you have to have them put up some collateral. What crypto does really well is it separates the innovation of like actually doing something with the capital required to do something. So operators are validating some software, but they shouldn't necessarily be the ones providing capital, just because we want to make operators be like as permissionless as possible, right? We don't just want to make it rich people. So we have these stakers. I'm just going to draw these guys as lines because there's a lot of them. And the stakers are providing capital and delegating that to these operators. The last thing I'll say is that the reason it's called restaking is because usually the capital that they're providing is staked ETH. Doesn't have to be, but for most of it, it is. And what the staked ETH is doing is it's earning yield by verifying, validating Ethereum, and now it's also validating your other AVSs. And so it's a much more capital efficient form of exchange. So here you can use EigenLayer, like just when should you be using EigenLayer? These aren't rules. This is like a rough approximation, and I'll talk more about these use cases later. But like if you're batching many transactions together, like we were in the cow swap example, if you're running an auction, which you might also do in the cow swap example, if you want access to real world information, remember these operators can run arbitrary node software, and that means they could run or collect prices and become oracles. They could like even just learn like who won the sports league, or like what is basketball going on now? NBA. Who won the NBA game today? And they could incorporate that into their software, because they're just running this arbitrary software, and more. Okay, that was a lot. I don't bite. I see there are questions in chat. Let's go through those. Hopefully this is making sense. Okay. I will make it better. Okay. It sounds like an order book DEX based on Eigen AVS. So this one is not an order book DEX. You can make an order book DEX, but the goal of this is to match taker orders together so that you have fewer that takers are paying fewer fees to makers. That makes sense combo. Let's say I ship this matching engine in Eigen AVS. How do I deploy? Does Eigen AVS supply Docker? I'll let Nader talk about that. AVSs can become an operator that issues intent-based transactions, right? Yes, so AVSs are not the operators themselves. AVSs have many operators there. Yes, we're seeing a lot of cool stuff happening with intents. Would love to talk more in in like the Discord or afterwards. Does it compete with Uniswap X? Sometimes yes. I'd argue that's a good thing. More competition, the better. Can you explain the restaking part again? Yeah, that's just saying that your stakers are providing capital for operators. But what capital are they providing? They're providing staked ETH. So this could be in the form of native staked ETH, or it could be in the form of it's state, right? Lido state. So someone is depositing this ETH into a staking protocol, like into Lido, and they're getting out state, and that's called staking. And then afterwards, they're using that same state and like using it to delegate to operators who are running AVSs, and like that's called restaked ETH. And that's what EigenLayer provides. It enables the Ether to be used not just to validate Ethereum, the chain, but any generalized number of AVSs, which we think is really powerful. It effectively makes it super easy to create an AVS or any decentralized network, because beforehand you had to worry about getting a bunch of operators and making sure they had capital, like so that they'd be economically aligned. EigenLayer kind of abstracts that away. We have a bunch of operators who are willing to run software, and and they have no opportunity cost for that capital because it's already earning staking rewards. Okay. Any other questions? Okay, sounds good. I'll move forward again. Yeah. How does an operator and staker get matched? They like the staker delegates to an operator, so they choose. So now I'm gonna just talk about a few ideas to get your brains flowing, to talk about like what are the different things you can do with Uniswap v4 hooks x EigenLayer AVSs. Fair warn, like caution, I am a DeFi degen and I also love EigenLayer because I mean I work there for a reason, right? So these are a bit nerdy, but the first idea is just a coincidence of Juan's example that we talked about, matching these taker orders and then settling them down onto either a Uniswap v4 pool or just an auction. Another very cool example I wanted to talk about is dynamic fees. So a lot of you guys know about dynamic fees. I think that's very popularized by his name like Alex Levchin. I think he's like 0x12345 on Twitter or something. Great guy. Met him in person. Wonderful dude. But dynamic fees can be useful, and Uniswap LPs fare worse during times of high volatility. So how can you solve for that? You just charge a higher fee during high volatility. How do you know when it's a high volatility? You have an external oracle that says, okay, an external oracle that determines the volatility of this specific pair. Maybe it's the ETHUSDC pair, maybe it's another pair. And really easy way of like, where are you going to get that oracle? It's not available on Chainlink, but what's cool about these AVS operators is that they're willing to find any source of truth or calculate it themselves. And so they can act as the oracle themselves. And then they can act as the oracle themselves, and then they can also set the LP swap fee. So you have like, let's say you have these LPs, they have this they have a fee, right? And then in order to calculate this, there's this off-chain there's ETH prices and USDC prices, which is hopefully just $1, and then using a predefined formula. And then DAO play into the fees, also using a predefined formula. So another example that I'm super excited about is how can you adjust LP positions for liquid staking token pools? So think you have STEET and ETH, right? So assuming you have these two tokens, originally it's going to start off at a price of 1-to-1, but over time the price of actually it'll be WSTEET. It'll be 1-to-1, but eventually the price of WSTEET is going to increase over time in terms of ETH, right? Because it is a rebasing token, so it just continue to earn value with respect to ETH. And there are two things you could do. One is you could say, okay, that's fine, and we're just going to have the LPs face this impermanent loss, face the impermanent loss and get arbed against by more savvy traders. Or you could have the LPs manually change their position every so often. Or what you could do is you could kind of like have the AVS operators they could be it could be a few different things. They could be like changing all of the LP positions up the curve, or they could like change the curve itself. But the way they would do this is they would act as an oracle for how much this liquid staking token is increasing with respect to ETH. So you have an oracle for the growth rate or the APR of WSTETH, and that affects how fast this you're changing alongside the curve. Okay. I actually I see a few questions. I'm just going to check. I actually no, we have time for a bit more questions. 3 more ideas. Sorry, I'll just run through these briefly and then happy to talk more offline. So what are dark pools? I think dark pools are super exciting. It's when you have effectively a bunch of like taker orders, like these market orders, and they want to be executed, but they're willing to wait and they want to be private, but they also want optimal prices. So what these guys can do is, let's say you have someone who wants like +5 ETH, someone who wants -5 ETH, and +2 ETH again. These would all send they would all send like this AVS of operators. And what they would do is they would match orders together, similar to before. But the question is how, like, at what price point do you match these orders at, right? And beforehand, we were saying that we would just match at the price of the pool. Here, we're saying that the AVS operators are going to find the best price possible. And what that means is they're going to look at the most liquid exchange, which is probably going to be Binance. And remember, these operators can run off-chain software, so they can do that. And Binance is going to have a best, like a price. They're going to have a best bid or a best buy and a best ask and a midpoint price. And what they're going to do is they're going to take this midpoint price and use that as the swap rate for this 5 ETH and like +5 ETH and -5 ETH. And then they'll hold on to the 2 ETH until they get another taker order. So this is a bit more complicated, but it's cool because you have you're incorporating the like transactions as well as the or like you're incorporating this matching engine as well as an oracle and really providing optimal prices. Okay, these next two are a bit too complicated, so I'll just again run through them very briefly. This is loss versus rebalancing is when like you have a price discrepancy between like an off-chain exchange like Binance, which does orders every second, and an on-chain exchange, which say it's on Ethereum, it can operate max every 13 seconds. So during these 13 seconds, you have like price discrepancy, and someone is going to arb that. They're going to they're going to pay a bunch of money to, they're going to have an auction and or like so the typical path is that they work with flashbots and block builders to become first in the block and they're effectively paying and they decide that via an auction, and that the proceeds of that auction go to Ethereum node validators. But ideally, it should go to LPs because LPs are the ones who are actually losing out from this loss versus rebalancing. They're being arbed against, right? And so what they would do, what would happen here is that you would have these AVS operators who could like run an off-chain auction and then give the first transaction slot to the winner of the auction, and then give those proceeds to the LPs themselves. Again, it's a bit complicated because it's like, how do you get those how do you make sure that transaction gets included in Ethereum? And there's a few ways of doing so. You can have just the AVS be the only person who can interact with the pool, or you could have the AVS operators be Ethereum node operators, but I'll stop there. And finally, there's an idea where you can run a shared state across all chains. And what this means is, let's say you have Ethereum mainnet, you have Arbitrum, and let's say you have new chain, new chain, right? And so for ETH USDC, there's a lot of liquidity. Let's say there's 100 mil in Ethereum mainnet, 10 mil in Arbitrum, and like 0.5 mil on new chain. If you're trading on new chain with any size, you're going to get some slippage, or like a lot of slippage. So what you could do is say, yes, in theory, like there is 110.5 mil of total liquidity. You could have these operators effectively act as an aggregation of state and provide prices based off of this 110.5 mil of liquidity. And LPs would go based off of this new price instead of what the operators are, instead of like what their X times Y equals K would be on their individual chain. Instead of that, they would go based off of the overall X times Y equals K on the 110.5 mil of liquidity. And this is super cool because you can have less slippage on these newer chains. You'd still be constrained for the actual transaction. You could only buy up to 0.5 mil of ETH, or like 0.25 mil of ETH on new chain, but you'd still get the prices as if they were as if they were 110.5 mil. So that is a lot of different ideas. Hopefully I did not the goal was to just really expand your mind. Like, what are all of the different ideas you can do when you have this decentralized network of operators? Because it's not immediately obvious, but it's so cool. So any questions, I'll answer the ones in chat, and then please feel free to ask. You can also raise your hand and ask in person, or like ask live. So is the service fee enough to cover the cost of an Eigen AVS? Yeah. So effectively, you need to design the economics around it to make sure that the service fee is worth it for the operators and stakers. We would love to work with you on that. For the purpose of the hackathon, just assume yes and don't worry about it. What would you say the difference between relying on an operator as an oracle versus using something like UMA's optimistic oracle system economics? Sorry, I don't know UMA's oracle system too well. I'll say a few things about EigenLayer, using EigenLayer or operators as oracle systems, is that you have infinite flexibility on what you want this oracle to be. We have people who are like using aggregating from very specific exchanges. Maybe you only want from one exchange, like in the dark pool example, you're only using the Binance price, so it leads to more precise prices. Maybe you're doing price feeds for stocks, and that has a lot of complications, right? Because you have dividends and you have stock splits, and how does that correlate into your oracle? You can effectively make it infinitely customizable based off of your needs. I don't know too much about UMA's oracle system, so not going to comment there. How is it guaranteed that none of the operators disclose the orders? They should be private if I understand it correctly. So yeah. I think that's Alex, that's an implementation detail. I'm not saying so they could disclose the orders, uh, but if you want to fix that, then you add in a privacy layer, potentially using like zero knowledge or like using TEEs. I don't understand TEEs very well, so I'm not gonna talk about it, but I have seen that it's been done before where sometimes the operators don't know anything about don't know anything about the orders. What another thing you could do is if you see these operators are front running on some other exchange, then yes, are front running these orders, then you could what you can do is slash them for that. Again, you want them to be economically aligned with your protocol. And so they have some stake that is there. Some stake that is tied to their protocol or like to their operator. And you can take that stake away. Happy to talk more about slashing offline. Lever idea is fire. Thank you, Jersey. Um, How do I make AVS? That's a question for Nader. He is so much smarter than me. We can discuss async in Discord afterwards, 100%. I will join, Nader will join as well.
Yeah, we're literally going to be
Toxic
building
order flow.
AVS, so or kind of like walking through a Hello World AVS from scratch.
Let's say I ship the matching engine in EigenAVS. Okay, we've done that one. Layer right now. I'm not gonna say like a specific one. I'll just say that you can go to app.eigenlayer.xyz/AVS and see all of the existing AVSs on mainnet. But we love all of our AVSs. LST rebalancing appears to require initial funding. What do you mean by initial funding? Are you saying the LPs are providing some capital? Because yes, that is intended. And then like the goal is to change the curve or like the position of the LP positions alongside the curve. But it would be the LPs who are providing the capital, just like normal. Why is Nader's name pronounced differently? You should, I think I'm pronouncing it right, but hopefully Nader will let you know. Okay, I think that's all of the questions. Any more, please? More questions. Let's do it. In this decentralized framework, how can a hook leverage a proprietary oracle and be trusted? So a great question, Nick. Effectively, you want this oracle to have economic security behind it. You have this decentralized network, all contributing to this oracle. If some are providing wrong prices, then they can be slashed. Again, I don't want to talk about slashing too much because it's important, but it's something that we can work through together as you build out an AVS, and it's not critical to the core design as long as you believe that it can work. Does it make sense to build a card game on top of EigenLayer, like poker? Maybe. Let's talk more. Reach out. By the way, we'll give contact information as well, but I'm at Ishan0x on Telegram. That's definitely the best way. And Twitter, if you want to give me a follow. Can an Eigen AVS interact with other AVSs? Yes, they can. Yeah. Okay. Any other questions? Would also love to hear your voices. Sorry, I'm taking up Nader's time. Yeah. Okay. Sounds good, Pomik. Thank you again, and I'll stop sharing my screen.
Yeah, that was really great. You were not taking up my time. We still have we still have a good 30 minutes or 40 minutes, I think. That was great. So do I go ahead and start presenting now?
Yeah, go for it.
Yep.
Okay, cool. All right. So I like Zoom because it allows you to actually choose exactly the section that you'd like to share. So let me try that. All right. Does that look okay to everybody?
Perfect.
All right. So there's basically going to be two parts to this presentation. It's going to be fairly short. And by the way, my name is Nader. You can pronounce it whatever way you like. I really don't care. But really excited to be here because I've been hearing and talking about hooks ever since I was working at Avara. Actually, we really were actually looking at the hooks showcase as a way for us to kind of get inspiration for our they were the open actions that we were working on over there at Lens, and a lot of cool stuff there. And I like the API, so glad that we're here talking about how to work with EigenLayer and maybe build some cool stuff. But yeah, this is gonna be broken up into two main parts. First, we're just gonna do a quick overview of what an ABS is, and then we're gonna actually look at a Hello World ABS, and we're gonna run the Hello World ABS and look at some of the code. And the Hello World ABS is very, very simple. It's just as simple as you can possibly be. In fact, it's so simple that it's probably not a real world use case. But I think the most important part is getting the mental model of all the moving parts. And that way you can then start building something and expand it into something more sophisticated later. If you want to, we have a bunch of resources that you can check out. We have our documentation, we have blog posts, and our YouTube channel, and a bunch of other things. And you can scan this QR code if you want, or you can go to docs.eigenlayer.xyz and click on resources. So we've already been given the definition of an ABS, but I'll just kind of double down and go back over it just one more time. And this definition, this is kind of coming from our own documentation. It's any system built on EigenLayer specifically that requires its own distributed validation semantics for verification. And that could be side chains, data availability layers, as we've seen with EigenDA. They can be VMs, keeper networks, oracles, bridges. It can be anything really that's a proof of stake network. And like Ishan mentioned, you can also go to eigenlayer.xyz/ABS to kind of see the different ABSs that are out there. Or if you want to see alpha, you can actually go to the Holsky test network and see people that are deploying their ABSs to testnet before they become live on mainnet. And an ABS is made up of two main parts. You have your on-chain smart contracts and you have your off-chain software. And the off-chain software is what the operator is running. This is going to be your proprietary functionality that is your, like I would say, the main part of your service. And then the on-chain stuff is just the verification of whatever is happening there. So broken up into two main parts, you have your contracts and you have your off-chain software. The contracts are what the state, and I would say we're going to dive into this in just a moment, but the tasks that your service is verifying. So a definition here of what exactly these contracts would be. Each ABS has its own set of contracts that hold state relevant to the service's functionality, such as what operators are running the service and how much stake is securing the service and any other on-chain functionality. A task, each ABS operational EigenLayer can be broken down into units called tasks. Each task describes the smallest unit of work that is to be done by the currently opted-in operator as per the ABS's distributed validation semantics, i.e., to kind of dumb this down, it's basically what needs to be verified. That's what a task is. And these can be emitted either on chain or off chain, and they're verified on chain. And then the operator is who actually runs your software. So you create your AVS, and when you want this to be deployed, essentially operators will opt in and they will run the off-chain code to participate in the network. And what we're going to be looking at in our demo here in just a moment is really, again, the most simple, like dumbed down version of what an AVS could be. So what we're running is an AVS that emits this hello world event. The hello world event essentially will be then verified on chain. That's kind of it. But here we have this line that kind of separates the off-chain and the on-chain stuff. So we have the operator that is essentially a long-running service. We have the Hello World smart contract, which is our proprietary code that we've written for our service. And then we have a consumer that's interacting with this service or with this AVS. So the AVS consumer, will basically be the entry point into the AVS. This could be a front-end application. It could be another protocol. It could be another AVS, but it's essentially who is going to be talking to your service. And to hopefully make this diagram even easier to understand, we'll actually walk through the code, and then we'll come back to that diagram. So the AVS that we're working with has really just three main files that we're going to be working in. We have two files that are TypeScript, which they are the service, and then we have one smart contract. And to kind of understand how this all works, we're going to kind of walk through the entry point, see how each function is invoking and talking to each other, and then we'll run this locally. And actually, let me pull up my terminal here and increase the font size. All right. So anyway, so we're back here at the code. The main entry point to this AVS is this main function right here. So the main function calls register operator, and then from there, it just sets up a listener. And the listener is just listening for new tasks that come in. So monitor new tasks is essentially just going to start setting up this listener, and then that's it. Our service is now running. So what does the monitor new tasks service look like? Well, all it's going to be doing is listening for this event to be emitted from our smart contract called new task created. Anytime new task created is invoked from our contract and that event is emitted, it will catch it here. We'll log out the task, and then we will try to verify that task by calling sign and respond to task, passing in the index, the block, and the task name. So with that being said, we have this listener set up here. What we need to do is also have another service that's going to be calling this method that's going to be, I guess, invoking and creating these tasks. So we will go ahead and look at that service. That service is essentially this right here. So we set up the listener, and then we come here and we invoke this function that's going to start creating these tasks. So start creating tasks just sets up an interval where we create a new task every 5 seconds. We create a random name, and then we call this function called create new task, passing in that name. So let's take a look at what create new task does. Create new tasks calls our smart contract, and we invoke create new task. So let's go to our contract and look at what that looks like. This is the create new task function. We get the name, set it as a variable. We get the block. We then store that in this all tasks hashes by passing in the task number. And then we emit that event that is that we were listening to earlier called new task created. So the listener gets set up. We start spitting out these new tasks. When a new task is created, we're getting this event emitted called new task created. So what happens when that new task created event is emitted? Well, we go back to our listener and we see that we have another function that we're calling here called sign and respond to task. So going back to the flow, listener gets set up, new task created, event is emitted. We catch that event here. And then this is kind of where the core AVS functionality is happening. This is where we're verifying. This is the verification. The whole point of like the AVS is the verification. So this is important, the most important part. We're calling sign and respond to task. This is calling another separate function in our contract. So sign and respond to tasks is right here. The main thing to focus on here is this method right here where we're calling contract.respond to task. So we'll go back to our contract here. We've looked at create new task. Now we're going to go to respond to task. Maybe I'll zoom out a little bit. And this is just all the verification that takes place. And this verification is very naive because it's just a hello world. We're going to check to make sure that the task hasn't already been recorded. We're going to then make sure that the operator hasn't already responded to this task. And then we're going to go ahead and update and add the new task response. We're going to then go ahead and update our array to basically say that this new task has already been responded to. And then we're going to event the final task responded event. And that's it. That's basically all of the functionality for this basic AVS. So let's go ahead and run this. And we're going to run three different, I guess we're going to run three different commands. First of all, we're going to go ahead and deploy the contracts, start our local node, our local chain, and have all of the contract on-chain stuff set up here. And this is just a make command that we have already set up. And by the way, all of this code and everything is executable, open source, and you can just basically clone this and run it yourself to kind of also get a better understanding of it. So we run this command. The network is set up with Anvil and Foundry. We deploy the contracts locally, and we are ready to go there. Now we're going to go ahead and start the operator. Remember, this isn't invoking anything. It's just setting up that listener. So now we've registered our operator, and we're now listening for new tasks. And then the final thing we need to do is just start creating those tasks. So every 5 seconds, this should create a new task, and we should see the verification happen over here. So transaction created, task name Hungry Fox 719. And we go here, we see that that one is created. And then now we're kind of seeing that those tasks are being created and our AVS is essentially running. And the only thing that is happening here that's probably a lot different than what you would have is instead of this, I would say, what is it? This like interval function that's just calling the new task every 5 seconds with a random number. This would actually hopefully be a real consumer interacting with your project or with your service with whatever, I guess, arguments that would be being passed there. All right, so that is kind of like a quick intro into a Hello World AVS. And the next thing I would say, if you want to learn more about building an AVS beyond what Ashan and me have already talked about, there's obviously a lot more to go into and learn. We have this AVS section in our documentation that goes into a lot more detail, really. One of the things you might look at is we also have a little bit more sophisticated or complex AVS called incredible squaring. This is using Go and our Go SDK, because we don't really have a TypeScript or a REST SDK quite yet, but we do have a Go SDK. So a lot of the RPC calls and other services that you might want to use have been abstracted away in the Go SDK, whereas with TypeScript, we actually had to manually write a lot of that. So yeah, I would just dive into the EigenLayer docs. We have a couple of really big pull requests that are going to be hopefully coming through in the next week that are going to even improve our AVS documentation even more. So I would definitely keep an eye out for that. And then if you want to run the Hello World AVS, you can also, go here to the Layer Labs GitHub. So github.com/layerlabs. And I will share that in the comments on Zoom in just a moment. But yeah, that's where the code that we ran earlier is. And I think that's about it. So I'm going to go ahead and stop sharing my screen and see if there are any questions. All right, cool. Yeah, any questions? And I am still fairly new at actually building AVSs. I've only been able to essentially clone and modify some of the existing AVSs that we have out there, and I've never built anything from scratch just yet. I'm actually working on a TypeScript version of Incredible Squaring. So if I can't answer some of these, I might try to point you to people that can. So I don't have a lot of experience. So one of the questions is, do I have any experience or any tips for integrating a hook with an AVS? Or do I have any best practices? I actually don't have any experience building hooks, so it's hard for me to say there. One idea that might be to look at some of the AVSs that are already out there and build something with one of those. That would definitely qualify you for the bounty, in my opinion, to the best of my understanding. Maybe Ashan can just double down that that's true. But if someone were to use an existing AVS like Lagrange or something like that, that would also qualify them for the bounty, right? Just anyone using EigenLayer in a cool way to build something as a hook.
Yeah.
Cool.
Use existing AVSs. Wi-Fi is bad.
Oh yeah, someone asks, in a scenario where the AVS is running on prod, how is the response task going to be verified? Typically, and if you look at the incredible squaring example, what we have set up is some type of almost like a quorum, where you say X number of nodes need to verify the same response for a given input. And then if that passes, then the task is then verified. Whereas in this case, we only had a single verification check and a single node. Yeah, that's exactly what I'm thinking. So yeah. And I'm wondering if I missed any other questions up here.
I responded to most of them.
Okay, cool.
Yeah, let's see. If you have any questions and we did not answer, please re-put in the chat or raise your hand and we are happy to talk from there.
Yes, when TypeScript SDK. Well, we have some alpha. I mean, we have a lot of stuff that we're working on because we just went through. I mean, the company is obviously fairly new, not hasn't been around that long. We just did mainnet. We just did the whole token announcement thing. We've been doing a lot of what I would say, big event announcement things. And now at least my team and a lot of the AVS team's main focus is on trying to build out a lot of high quality developer tooling and and expand the developer ecosystem. And also we are working on a lot of incentive programs. So we have some really, really cool stuff that we're proposing that I would say is going to hopefully be very compelling to a lot of developers. So hopefully we can get all that stuff approved and passed and announced in the next few weeks or maybe month or so. So just keep an eye out for a lot of that stuff. But a lot of our focus is on building out higher quality and more, I would say, expanded SDKs outside of just Go. So TypeScript, Rust are at the top of our list, also considering Python. And we also are working on a lot more advanced reference architectures. So we want to have like an Oracle reference architecture. We want to have a coprocessor advanced reference architecture. We want to have multiple versions of Hello World in different languages and also different of different complexity. So if you have an idea, you can just essentially spin up a reference architecture that's like 80% of the way there. So you don't have to build everything from scratch. So that's a big focus. If we can get like a lot of those, and we are going to have a lot of those, it's just a matter of time.
Awesome. Thank you so much for coming. You guys are great. This was awesome. This was the moment we announced that this was coming up. There was a lot of hype in the chat. So this was a long time coming. I am sure there will be lots of people exploring, looking into building a hook, whether it's in this upcoming hackathon or beyond. So I'm excited to see the conversation happen on Discord and the EigenLayer channel. We will upload the recording for this in the guest workshop channel. I dropped a link to that AVS repo also on the EigenLayer channel. So thank you again, both of you. Any other last comments?
I'll say last thing I'll say to check out is our website called build.eigenlayer.xyz. I'll put that in chat as well.
Oh, right. Yeah.
A list of all of the resources available, period. It might be a bit overwhelming, but it's fairly like you can see what you want to look at. So there's like intros to EigenLayer that explain it much better than I did because Sriram is one of the best talkers I've ever heard. And then there's like an article called "You Could Have Invented EigenLayer" by Kaido. I really like that. There's more repos and there's developer documentation. There's AVS repos and documentation, so you can look at those as well.
Amazing. Thank you, everyone.
Yeah. Thank you for having us. We appreciate everyone's time today.
Yes, there's a really cool group of people here. It was impressive. I'm excited, and I will see you all on Discord.
Awesome. Thank you, everyone. Have a great rest of the day. I shall see you around then.
Bye, everyone.
Cheers.
Bye.